Now comes Chapter 3, Our Changing Earth. The lithosphere is broken into a number of plates known as the lithospheric plates. Lithospheric plates are the Earth's crust consists of several large and some small rigid, irregularly shaped plates, slabs which carry continents and the ocean floor. You will be surprised to know that these plates move around very slowly, just a few millimeters each year. This is because of the movement of the molten magma inside the Earth. The molten magma inside the Earth moves in a circular manner as so the movement of these plates causes changes in the surface of the Earth. The Earth movements are divided on the basis of the forces which cause them. The forces which act in the interior of the earth are called as endogenic forces, and the forces that work on the surface of the earth are called as exogenic forces. Endogenic forces sometimes produce sudden movements and at the other times produce slow movements. Sudden movements like earthquakes and volcanoes cause mass destruction over the surface of the earth. A volcano is a vent opening in the earth's crust through which molten material erupts suddenly. Similarly, when the lithospheric plates move, the surface of the earth vibrates. The vibrations can travel all around the earth. These vibrations are called earthquakes. The place in the crust where the movement starts is called the focus. The place on the surface above the focus is called the epicenter. Vibrations travel outwards from the epicenter as waves. Greatest damage is usually closest to the epicenter, and the strength of the earthquake decreases away from the center. Focus is where the earthquake occurs. It is the origin of the seismic energy. Although earthquakes cannot be predicted, the impact can certainly be minimized if we are prepared beforehand. Some common earthquake prediction methods adopted locally by people include studying animal behavior. Fish in the ponds get agitated, snakes come to the surface. An earthquake is measured with a machine called a seismograph. The magnitude of the earthquake is measured on the Richter scale. An earthquake of 2.0 or less than can be felt only a little. An earthquake over 5.0 can cause damage from things falling. A 6.0 or higher magnitude is considered very strong, and 7.0 is classified as a major earthquake. So, a case study of earthquake is there. Earthquake hits Bhuj, a massive earthquake measuring 6.9 on Richter scale, hit Bhuj town on 26 January 2001. School worst affected. At least 971 students and 31 teachers are feared to have lost their lives following the collapse of school buildings. Bhuj relief effort blighted. 3 days after the quake, concern rose about food, blankets, and medical supplies on not reaching everyone. Destruction of Bhuj phone lines, water pipelines, and power stations transmission lines were knocked out. Fire in the city. Hundreds of fires started as charcoal cookers overturned. Emergency declared in quake zone. The president declares a state of emergency. CMs appeal to the center. Gujarat appeals for financial help. The Chief Minister of Gujarat has launched an appeal for the center to deal with the disaster. Earthquake preparedness. Where to take shelter during an earthquake. Safe spot under a kitchen, counter, table or desk, against an inside corner or wall. Stay away from fireplaces, areas around chimneys, windows that shatter, including mirrors and picture frames. Be prepared. Spread awareness amongst your friends and family members and face any disaster confidently. Major landforms. The landscape is being continuously worn away by two processes: weathering and erosion. Weathering is the breaking up of the rocks on the Earth's surface. Erosion is the wearing away of the landscape by different agents like water, wind, and ice. The eroded material is carried away or transported by water, wind, etc., and eventually deposited. This process of erosion and deposition create different landforms on the surface of the earth. Work of a river. The running water in the river erodes the landscape. When the river tumbles at steep angle over very hard rocks or down a steep valley inside it forms a waterfall. As the river enters the plain, it twists and turns, forming large bends known as meanders. Due to continuous erosion and deposition along the sides of the meander, the ends of the meander loop come closer and closer. In due course of time, the meander loop cuts off from the river and forms a cut-off lake, also called an oxbow lake. At times, the river overflows its banks. This leads to the flooding of the neighboring areas. As it floods, it deposits layers of fine soil and other material called sediments along its banks. This leads to the formation of a flat, fertile floodplain. The raised banks are called levees. As the river approaches the sea, the speed of the flowing water decreases and the river begins to break up into a number of streams called distributaries. The river becomes so slow that it begins to deposit its load. Each distributary forms its own mouth. The collection of sediments from all the mouths form a delta. Work of sea waves. The erosion and deposition of the sea waves gives rise to coastal landforms. Sea waves continuously strike at the rocks, cracks develop. Over time, they become larger and wider. Thus, hollow like caves are formed on the rocks. They are called sea caves. As these cavities become bigger and bigger, only the roof of the caves remain, thus forming sea arcs. Further erosion breaks the roof and only walls are left. These wall-like features are called stacks. The steep, rocky coast rising almost vertically above seawater is called sea cliff. The sea waves deposit sediments along the shores, forming beaches. Work of ice. Glaciers are rivers of ice which too erode the landscape by bulldozing soil stones to expose the stones to expose the solid rock below. Glaciers carve out deep hollows there. As the ice melts, they get filled up with water and become beautiful lakes in the mountains. The material carried by the glacier, such as rocks, big and small sand, and silt, gets deposited. These deposits form glacier moraines. Walk of wind. Have you ever visited a desert? An active agent of erosion and deposition in the deserts is wind. In deserts, you can see rocks in the shape of a mushroom. Commonly called mushroom rocks, winds erode the lower section of the rock more than the upper part. Therefore, such rocks have narrower base and wider top. When the wind blows, it lifts and transports sand from one place to another. When it stops blowing, the sand falls and gets deposited in low hill like structures. These are called sand dunes. When when the grains of sand are very fine and light, the wind can carry it over very long distances. When such sand is deposited in large areas, it is called loess. Large deposits of loess is found in China.